October 12th, 1944, 3:47 a.m. Outside Aachen, Germany. The metallic click of a radio dial being turned echoed through the cramped interior of Panzer IV number 431, where Oberleutnant Klaus Weber pressed his ear against the static-filled headphones, straining to intercept American tank communications that had been flooding the airwaves with an impossible clarity for the past 3 weeks. The claim seemed so preposterous that Weber had initially dismissed it as Allied propaganda designed to demoralize German forces. American Sherman tanks, those mechanically inferior Ronsons that burst into flames at the first penetrating hit, supposedly possessed radio communication systems more advanced than anything the Wehrmacht had ever deployed. Systems so sophisticated they could coordinate hundreds of armored vehicles across vast battlefields with the precision of a symphony orchestra conducted by an invisible maestro. Amerikaner mit besseren Funkgeräten als wir? Weber had scoffed to his radio operator just 3 days earlier, lighting a cigarette with trembling fingers as Allied artillery thundered in the distance. These are the same people who think a Sherman can match our Tigers. Next, they'll tell us their infantry carries portable telephones to call their mothers from the battlefield. But the evidence had been accumulating like snow in a Bavarian winter, each intercepted transmission adding another layer to an increasingly undeniable reality that challenged everything the German High Command had assumed about American industrial capabilities and battlefield coordination. Weber's own field reports, meticulously documented in his leather-bound logbook, told a story that his superiors in Berlin would have branded as defeatist fantasy if not for the corroborating testimony flooding in from every sector of the Western Front. Technical Sergeant Michael O'Brien of the 3rd Armored Division had written in his journal entry dated October 8, 1944, "The Krauts still don't understand how we're hitting them so hard and so fast. They keep looking for some secret weapon, some new tank design, but it's not the steel that's winning this war. It's the voices. Every Sherman crew can talk to every other Sherman crew, to the artillery, to the air support, to command, all at the same time. We're fighting like a single organism while they're fighting like a bunch of separate animals." The SCR 508 radio system installed in every American Sherman tank represented a technological leap that German intelligence had catastrophically underestimated. A frequency-modulated marvel of American engineering that operated on 18 separate channels with a transmission range of 15 miles under optimal conditions. Powered by a dynamotor system that drew its energy directly from the tank's main electrical system with an efficiency that would have impressed the engineers at Siemens if they had been allowed to examine it without the distraction of incoming high-explosive shells. Each radio weighed exactly 68 pounds, contained 127 vacuum tubes arranged in circuits of bewildering complexity, and could switch between channels in less than 2 seconds, allowing Sherman commanders to coordinate with infantry, artillery, air support, and adjacent tank units while simultaneously monitoring enemy frequencies and adjusting their tactical approach in real time based on information flowing through an electromagnetic nervous system that connected every American armored unit on the battlefield. It was the mathematics of synchronized destruction, calculated in frequencies and amplified through industrial precision. Weber remembered the morning of October 9th, when his panzer company had attempted to ambush a column of Shermans moving through the Hurtgen forest, positioning themselves in a perfect L-shaped formation that should have resulted in the destruction of at least 6 American tanks before they could effectively respond. Instead, the lead Sherman had spotted Weber's carefully concealed Panzer IV, transmitted its position to the entire American formation in a burst of clear, unencrypted English that Weber's radio operator had intercepted and translated in real time. And within 30 seconds, every American tank in the column had adjusted its position and brought its main gun to bear on predetermined targets while simultaneously calling in artillery support that began falling with surgical precision exactly 90 seconds later. The engagement had lasted exactly 4 minutes and 37 seconds, measured by Weber's stopwatch from first shot to final explosion, during which time the Americans had destroyed 3 German tanks, disabled 2 more, and forced the remainder to retreat while suffering only superficial damage to one Sherman's track assembly that was repaired in place within 20 minutes by a maintenance crew that had been summoned by radio before the engagement had even concluded. "Impossible," Major Ernst Guderian had muttered when Weber submitted his after-action report, staring at the typed pages as if they contained evidence of supernatural intervention. 12 American tanks cannot coordinate that precisely. They are not Germans. They lack the discipline for such operations. But precision, was exactly what the Americans had achieved through industrial standardization rather than military tradition, equipping every single one of their 60,000-plus Sherman tanks with identical radio equipment that allowed crews trained in Kansas and Texas and California to communicate with the same clarity and coordination as units that had trained together for years, creating a battlefield network that transformed individual tanks into nodes in a vast information processing system that could adapt and respond faster than any human commander could issue orders through conventional military hierarchy. The wireless operators at German Army Group B headquarters in Münster had been tracking American radio traffic since September 15th, when Staff Sergeant Heinrich Müller first noticed the peculiar pattern of coordinated transmissions that seemed to violate every principle of battlefield communications security that the Wehrmacht had learned through 5 years of mechanized warfare across Europe, Africa, and the Eastern Front. "Sir, the Americans are broadcasting their tactical movements in the clear," Müller had reported to Oberst Friedrich von Manstein, his voice carrying the bewildered tone of a man witnessing something that contradicted his fundamental understanding of military reality. "They're not even using codes. They're discussing target assignments, ammunition status, fuel levels, mechanical problems, everything. It's as if they want us to hear them." Then von Manstein had initially assumed this represented either American incompetence or an elaborate deception designed to mask their real intentions. But 3 weeks of continuous monitoring had revealed a communications network of staggering sophistication that operated with such overwhelming volume and complexity that German intelligence units could intercept and translate only a tiny fraction of the total traffic flowing through American tank formations at any given moment. The captured technical manual for the SCR-508 radio system, retrieved from a destroyed Sherman near St. Vith by Feldwebel Anton Richter on October the 3rd, contained specifications that seemed to describe equipment from a science fiction novel rather than battlefield reality: automatic frequency control circuits that prevented signal drift, noise limiters that maintained clarity even under heavy electrical interference, and modulation systems that could transmit voice communications with such fidelity that individual American tank commanders could be identified by their distinctive accents and speaking patterns even through the static and chaos of armored combat. Private James Morrison of the 4th Armored Division had written to his sister in Detroit on October 10th, "You wouldn't believe how different this is from what we trained for back at Fort Knox. Every tank can talk to every other tank, all the time. When we're moving across country, it sounds like a party line with 30 people all talking at once. But somehow it all makes sense. The sergeant calls out targets, the lieutenant coordinates with artillery, the captain talks to the planes, and somehow we all end up shooting at exactly the right things at exactly the right time, and so it's like having eyes and ears everywhere." German tank crews, by contrast, relied on flag signals, hand gestures, and primitive radio equipment that worked effectively only at ranges under 3 miles and frequently suffered from interference, mechanical failure, and the simple reality that most panzer commanders had learned their tactical skills in an era when battlefield coordination meant visual contact and shouted orders rather than the electromagnetic orchestration of hundreds of vehicles across dozens of square miles. The mathematical disparity became clear when German intelligence analysts calculated that a typical American armored division possessed 168 Sherman tanks, each equipped with radio systems capable of operating on 18 different frequencies, creating a potential communications matrix of 3,024 simultaneous channels that could be reconfigured instantly based on tactical requirements, weather conditions, enemy interference, or simple operational preference. German armored divisions, when they could field them at full strength, operated with perhaps 60 functional tanks equipped with radio systems that worked reliably on 3 frequencies under ideal conditions. The industrial implications staggered even veteran Wehrmacht officers who had witnessed the shocking abundance of American equipment throughout the Normandy campaign and the subsequent Allied advance across France and Belgium. Each SCR-508 radio system required 127 vacuum tubes manufactured to tolerances measured in thousandths of an inch, assembled by workers trained specifically for electronics production rather than general manufacturing, tested individually before installation, and supported by a logistics network that could deliver replacement components to frontline maintenance units within hours of receiving requisition orders. Hauptmann Georg Steiner of the 2nd Panzer Division had captured an American radio technician near Nancy in late September and spent 3 hours interrogating the young sergeant about American communications procedures, expecting to uncover some elaborate tactical doctrine that explained their apparent coordination advantages. Instead, Steiner discovered that the Americans had achieved their communications superiority through the simple expedient of manufacturing enough high-quality radio equipment to equip every single tank in their inventory with identical systems, training every crew member to operate the equipment competently, and establishing supply lines capable of maintaining thousands of complex electronic devices under battlefield conditions indefinitely. "We have better individual tanks," Steiner had written in his personal diary that evening, "but they have better systems. A single Tiger can destroy 3 Shermans in direct combat, but 6 Shermans working together can destroy a Tiger before the Tiger crew realizes they are under coordinated attack. This is not tactics. This is arithmetic." The captured American supply manifest dated October 5, 1944, discovered in an abandoned command post near Metz, listed radio equipment deliveries that defied German comprehension. 847 complete SCR-508 systems, delivered to forward maintenance depots during the first week of October alone, along with 12,000 replacement vacuum tubes, 3,400 spare antenna assemblies, 8,900 feet of coaxial cable, and 156 complete spare transmitter units, all manufactured in factories that continued operating at full capacity while German industrial production collapsed under Allied bombing campaigns and raw material shortages. The wireless intercept logs maintained by German Army Group B revealed the casual abundance with which American forces treated equipment that represented months of scarce production in German factories. Sherman crews discarding damaged radio sets rather than attempting field repairs, requesting replacement equipment for units that suffered minor component failures, and operating multiple backup communication systems simultaneously to ensure redundancy in case primary systems failed during combat operations. The breakthrough moment came on October 14, 1944, at 11:23 a.m. when Hauptmann Wilhelm Krauss of the German 116th Panzer Division intercepted a routine American radio transmission that would fundamentally alter his understanding of industrial warfare and force him to confront the mathematical impossibility of German victory against an enemy that could afford to waste advanced technology as casually as the Wehrmacht rationed bread. Baker 27 to Charlie Command. My radio's acting up, getting some static on channel 12. Requesting permission to swap out the entire unit after we finish this sweep. Came the voice of an American tank commander whose casual tone suggested he was discussing a minor inconvenience rather than the replacement of equipment that would have taken German engineers 3 months to manufacture from increasingly scarce materials and components diverted from desperately needed air defense systems. Krauss had been monitoring American frequencies for 6 weeks, initially hoping to gather tactical intelligence that might give German forces some advantage in the increasingly hopeless battles raging across the Siegfried Line. But instead, he had documented a communications network that operated with such redundancy and sophistication that American tank crews could afford to discard malfunctioning radios the way German soldiers discarded empty ammunition clips. The War Diary of Technical Sergeant Robert Chen, captured near Aachen on October 16th, when his Sherman threw a track during a routine patrol, contained entries that read like inventory reports from a peacetime factory rather than battlefield accounts from contested territory. October 12th, swapped out radio in Tank 23, minor tube failure in primary amplifier stage. October 13th, installed new antenna assembly on Tank 18, old one damaged by tree branch during forest movement. October 14th, replaced entire SCR-508 unit in Tank 31, crew reported intermittent reception issues on channels 15-18. German radio technicians, by comparison, spent weeks cannibalizing components from multiple damaged units to create a single functional radio system, soldering individual vacuum tubes with the care of jewelers crafting precious ornaments, while their American counterparts simply requisitioned complete replacement assemblies from supply depots that maintained thousands of spare units in climate-controlled warehouses protected by anti-aircraft batteries and staffed by specialists trained in electronics maintenance rather than general mechanical repair. The captured American Field Manual FM 17-67, Radio Communication and Armored Units, described operational procedures that assumed unlimited access to replacement equipment, spare parts, and technical support services that existed nowhere in the German military structure, even during the triumphant campaigns of 1940 and 1941, when Wehrmacht logistics functioned at peak efficiency and German factories operated without the constant disruption of Allied bombing raids. Chapter 7 of the manual, titled Equipment Replacement and Maintenance Schedules, specified that SCR-508 radio systems should be replaced entirely if more than 3 vacuum tubes failed within a 30-day period. that antenna assemblies showing any sign of corrosion or mechanical damage should be discarded immediately rather than repaired, and that backup radio systems should be tested daily and replaced weekly to ensure optimal performance under combat conditions. Obergefreiter Hans Müller, a communications specialist with the 21st Panzer Division, had spent the entire month of September attempting to repair a single damaged radio receiver using components salvaged from 4 other destroyed units. Working by candlelight in a bombed-out farmhouse near the Belgian border while American tank formations moved past his position with radio traffic so dense and continuous that the electromagnetic spectrum itself seemed to vibrate with their coordinated communications. "They replace equipment faster than we can repair it," Muller wrote to his wife on October 18th, in a letter that would be intercepted by Allied intelligence and filed in archives that documented the collapse of German technological confidence. "Yesterday I heard an American tank commander request a complete radio replacement because his unit was only receiving signals clearly on 16 of 18 available channels. 16 channels! Our best equipment works on 3 channels when the weather is perfect." The industrial mathematics underlying American radio production had been calculated by German economists in a classified report dated September 30th, 1944, that estimated American factories were manufacturing SCR 508 radio systems at a rate of 2,400 units per month, while simultaneously producing backup components at rates that exceeded total German electronics production by factors that the report's authors described as economically incomprehensible given known American resource limitations and competing military production requirements. The German analysis failed to account for American industrial practices that treated military electronics as a mass production challenge rather than a precision manufacturing problem. Utilizing assembly line techniques developed in automobile factories to produce radio equipment with the same standardization and quality control that American industry applied to manufacturing civilian consumer goods before the war redirected production capacity toward military applications. Each American SCR 508 radio contained components manufactured by dozens of different companies across the continental United States. Coordinated through supply chains that delivered raw materials from mines in Montana and Michigan to electronics factories in Ohio and Pennsylvania, where workers trained specifically for radio production assembled vacuum tubes, capacitors, transformers, and circuit boards with tolerances maintained through statistical quality control rather than individual craftsmanship. The captured production schedule from the Bendix Aviation Corporation facility in Baltimore, discovered in the briefcase of a downed American transport pilot near Cologne on October 19th, revealed manufacturing targets that exceeded total German electronics production for the entire war: 15,000 vacuum tubes per week, 8,000 transformer assemblies per week, 12,000 capacitor units per week, all produced by workers who had been manufacturing civilian radios and automobile components 18 months earlier, but had been retrained for military electronics production through standardized procedures that emphasize speed and consistency over individual skill. The morning of October 21st, 1944, brought a revelation that would haunt Oberst Heinrich Zimmermann for the remainder of his abbreviated military career, when intercepted American communications revealed that individual Sherman tank crews were discarding perfectly functional radio equipment simply because newer models had arrived from supply depots, creating a cascade of abundance that violated every principle of wartime resource management that Zimmermann had learned during 23 years of German military service. Fox 3 to base. We've got the new SCR 508A units coming up with the supply convoy. Do you want us to swap out our current radios or just keep them as backups? The transmission crackled through Zimmermann's headphones at 6:15 a.m. as he monitored American frequencies from his command bunker 12 kilometers east of the Rohr River, where German forces had been attempting to establish defensive positions against Allied advances that seemed to accelerate with mechanical precision, despite the approach of winter weather that should have slowed armored operations to a crawl. The SCR 508A represented an improved version of the standard American tank radio, incorporating technical refinements that German engineers would have celebrated as breakthrough achievements, but which American forces treated as routine equipment upgrades, installing the new systems in their Shermans with the casual efficiency of mechanics replacing spark plugs in delivery trucks, rather than the reverent care that German technicians reserve for any piece of functioning electronics equipment. Lieutenant Colonel James Patterson of the 9th Armored Division had noted in his operational report dated October 18th, "The new A-model radios show significant improvements in signal clarity and range extension, particularly useful for coordinating with artillery units at distance exceeding 12 miles. Recommend immediate replacement of all B-model units currently in service, with replaced radios to be distributed to mechanized infantry units or retained as theater reserve equipment for emergency replacement purposes. German forces, meanwhile, continued operating with radio equipment designed in 1938 and manufactured in increasingly small quantities by factories that had been converted to producing components for V-2 rockets, jet aircraft engines, and other desperate technological gambits that consumed resources without providing the massive quantitative advantages that American industry achieved through standardized mass production of proven designs rather than experimental weapon systems. The technical specifications captured in a partially burned American manual retrieved from a destroyed supply depot near Düren revealed the extent to which American radio technology had evolved beyond German capabilities. The SCR-508A incorporated automatic gain control circuits that maintained consistent signal strength across varying distances, crystal-controlled frequency stability that prevented signal drift during extended operations, and modulation systems that could transmit clear voice communications even through the electrical interference generated by hundreds of operating tank engines, vehicle generators, and radio transmitters operating simultaneously across concentrated areas. Feldwebel Kurt Richter, a signals specialist who had served with distinction during the campaigns in Poland, France, and the early stages of Operation Barbarossa, had spent 3 weeks attempting to reverse engineer a captured SCR-508 radio system, hoping to identify design principles that German engineers might adapt for their own equipment, but instead discovered manufacturing techniques that required industrial infrastructure, precision tooling, and quality control systems that no longer existed anywhere in the shrinking German economic sphere. The Americans build their radios like they build their automobiles, Richter wrote in his technical assessment submitted to Army Group B headquarters on October 20th. Every component is manufactured to identical specifications, tested individually, assembled by workers trained for specific tasks rather than general electronics work, and supported by supply chains that can deliver replacement parts faster than we can identify what needs to be replaced. This is not superior engineering, bomkoi. This is superior economics. The mathematics of American radio production overwhelmed German analysts who attempted to calculate the industrial requirements necessary to equip tens of thousands of armored vehicles with sophisticated communications equipment while simultaneously producing the vast quantities of ammunition, fuel, spare parts, food, medical supplies, and thousands of other items required to maintain mechanized armies operating thousands of miles from their home bases. American factories were manufacturing SCR-508 radio systems at rates that exceeded 3,200 units per month by October 1944, while German electronics production had declined to fewer than 400 comparable units per month despite desperate efforts to maintain production levels through the use of slave labor, substitute materials, and manufacturing processes that prioritized quantity over the quality standards that had previously distinguished German engineering from foreign competition. The captured American logistics report dated October 15, 1944, documented radio equipment deliveries that represented more sophisticated electronics than the German military had deployed during the entire war. 1,047 SCR-508 radio systems delivered to forward supply depots during the second week of October, along with 18,600 replacement vacuum tubes, 4,200 antenna assemblies, 27,000 feet of coaxial cable, 890 spare modulator units, and 156 complete backup transmitter systems, all manufactured in American factories that continued expanding production capacity while German industrial cities disappeared under Allied bombing campaigns. The wireless intercept logs maintained by German Army Group B documented American communications traffic that operated with such volume and complexity that German monitoring stations could process only approximately 15% of total transmissions, creating intelligence gaps that left German commanders virtually blind to American tactical intentions despite technically successful interception of individual radio messages. Captain Theodore Williams of the 3rd Armored Division had written in his after-action report following the engagement at Stolberg, German forces continue to demonstrate excellent individual tank gunnery and tactical positioning, but their communications limitations prevent them from coordinating effective responses to our multi-axis attacks. They fight like individual hunting parties while we operate like a single organism with thousands of eyes and voices. The Industrial Revolution reached its crescendo on October 24, 1944, when Major Friedrich von Seckendorf Aberdar witnessed an American logistics operation that would fundamentally destroy his understanding of resource allocation and force him to confront the terrifying mathematics of an enemy nation that possessed such overwhelming productive capacity that it could afford to equip ordinary tank crews with communications technology superior to anything available to German elite formations, while simultaneously maintaining supply lines that treated advanced electronics as expendable commodities rather than precious strategic assets. The scene unfolded at 2:30 p.m. near the destroyed railway bridge at Jülich, where von Seckendorf-Aberdar observed through his field glasses as American supply vehicles delivered what appeared to be routine replacement equipment to a Sherman tank company that had been operating in the sector for less than 48 hours, but already required radio maintenance that would have consumed months of German technical resources and irreplaceable specialized components. American supply sergeants unloaded 17 complete SCR-508 radio systems from standardized transport containers, along with enough spare components to equip an entire German panzer regiment. Treating the sophisticated electronics with the casual efficiency of warehouse workers distributing office supplies, rather than the reverential care that German technicians reserve for any piece of functioning communications equipment, while American tank crews chatted and smoked cigarettes, as if the replacement of advanced radio systems represented nothing more than routine vehicle maintenance. The SCR-508 radio system incorporated technological innovations that German scientists had theoretical knowledge of, but lacked the industrial infrastructure to implement on any meaningful scale. Frequency modulation circuits that eliminated most forms of atmospheric interference, automatic volume control systems that maintained consistent audio levels regardless of signal strength variations, and crystal oscillator frequency control that provided stability measurements accurate to within 0.01% across temperature ranges from -30 to +60 degrees Celsius. Each radio contained exactly 127 vacuum tubes manufactured to specifications that required precision tooling, quality control procedures, and material consistency that exceeded the capabilities of German electronics factories even during peacetime production when skilled workers, high-quality materials, and uninterrupted electrical power were readily available rather than scarce resources allocated through increasingly desperate bureaucratic rationing systems. The captured American Technical Manual TM 11279, Maintenance and Repair of Radio Set SCR 508, described replacement procedures that assumed unlimited access to spare parts, specialized tools, and replacement components that existed in such abundance that American maintenance protocols specified discarding entire circuit assemblies rather than attempting component-level repairs that might compromise long-term reliability or operational performance under combat conditions. Gefreiter Anton Weber, a radio technician with the 12th SS Panzer Division, had spent 6 weeks attempting to repair 5 damaged German radio sets using components cannibalized from 12 other destroyed units. Working in a converted cellar near Aachen, while American tank formations passed overhead with communications traffic so dense and continuous that the electromagnetic spectrum itself seemed saturated with their coordinated transmissions operating on frequencies that German equipment could barely receive, much less jam or intercept effectively. They throw away more radio equipment in a single day than our entire division has received since June, Weber wrote in his diary entry dated October 22nd. Yesterday, I watched American tanks discarding perfectly functional antenna assemblies because newer models had arrived with their supply convoy. The discarded antennas were better than anything we have ever been issued, but the Americans left them beside the road like empty ration cans. The mathematical impossibility of German victory became apparent when intelligence analysts calculated that American forces were operating approximately 49,000 Sherman tanks across all theaters of operation, each equipped with radio systems that incorporated more advanced electronics than the total German communications inventory, while simultaneously maintaining production rates that delivered replacement equipment faster than German forces could destroy it through combat operations, sabotage, or strategic bombing campaigns. American factories were producing SCR-508 radio systems at rates exceeding 4,100 units per month by late October 1944, manufactured in facilities that operated 3 shifts per day using standardized assembly procedures, precision tooling, and quality control systems that maintained consistent performance specifications across hundreds of thousands of identical units. While German electronics production had collapsed to fewer than 200 comparable radio systems per month, despite increasingly desperate measures to maintain any level of sophisticated equipment manufacturing. The captured American production statistics, discovered in the briefcase of a liaison officer, killed during the failed German offensive near Schmidt on October 26th, documented industrial output that defied German comprehension. 847,000 vacuum tubes manufactured during September 1944, 234,000 transformer assemblies, 200,000 capacitors, 156,000 resistors, 89,000 coil assemblies, and 45,000 crystal oscillators, all produced by American factories that continued expanding capacity while German industrial cities burned under Allied bombing campaigns that targeted the precision manufacturing facilities necessary for electronics production. The wireless interception logs maintained by German Army Group B revealed the casual abundance with which American forces treated communication security, broadcasting tactical information with such volume and redundancy that German monitoring stations could intercept thousands of individual transmissions while still missing the majority of American radio traffic, creating intelligence overload that prevented effective analysis of the information that German operators successfully recorded and translated. Captain Michael O'Reilly of the 4th Armored Division had noted in his weekly intelligence summary, German radio discipline remains excellent, with minimal transmission activity and careful use of encryption when they do communicate, but their limited communications capacity prevents them from coordinating the complex multi-unit operations that our radio networks enable as a matter of routine procedure. They possess superior individual equipment in many cases, but they cannot achieve the systematic coordination that wins modern battles. It was the mathematics of electromagnetic dominance, calculated in frequencies and measured in the industrial capacity to maintain thousands of sophisticated communication systems under battlefield conditions indefinitely. The central set piece unfolded on October 27, 1944, during the Battle of the Hurtgen Forest, when Oberst Karl von Luttwitz positioned his remaining 23 Panzer IVs and 8 surviving Tigers in a perfectly executed ambush formation along the Kahl River Valley, utilizing terrain advantages, camouflage discipline, and tactical positioning that represented the accumulated wisdom of 5 years of mechanized warfare, only to witness the mathematical inevitability of defeat against an enemy whose communications superiority transformed individual Sherman tanks into nodes in a vast information network that responded to threats with the coordinated precision of a single massive organism. The German ambush began flawlessly at 7:42 a.m. when the lead elements of Combat Command B 9th Armored Division entered the killing zone exactly as von Luttwitz had predicted, with 12 Sherman tanks advancing in column formation along the forest road, while German gunners adjusted their aim and prepared to unleash concentrated fire that would have devastated any conventional armored formation attempting to traverse the narrow, tree-lined approach to the river crossing. Von Luttwitz gave the firing command at 7:44 a.m., and his concealed panzers opened fire simultaneously, achieving first-round hits on 3 Sherman tanks and seriously damaging 2 others in an opening salvo that should have triggered the panic, confusion, and tactical disintegration that German forces had exploited to devastating effect during the early years of the war when superior training, equipment, and battlefield coordination had enabled smaller German formations to defeat larger Allied forces through tactical surprise and overwhelming local superiority. Instead, within 18 seconds of the first German shot, every Sherman tank in the American formation had received precise targeting information transmitted through their SCR-508 radio systems, identifying the locations of concealed German positions with coordinates accurate to within 10 meters, while simultaneously calling for artillery support, airstrikes, and reinforcement from adjacent units that began responding to the ambush before German tank commanders had completed their initial target engagement procedures. The American response demonstrated industrial warfare transformed into electromagnetic coordination, as Sherman commanders transmitted firing solutions, ammunition requests, damage assessments, and tactical adjustments through radio networks that operated with such clarity and redundancy that individual tank crews could monitor communications from units operating dozens of miles away while maintaining constant contact with their immediate tactical formations, artillery support elements, and air liaison officers who began vectoring fighter bombers toward German positions within 90 seconds of first contact. Technical Sergeant Raymond Martinez of the 9th Armored Division later wrote in his combat journal, "The Krauts had us cold, perfect ambush position, good fields of fire, probably would have wiped us out completely if we'd been fighting with World War I communications, but every tank crew knew exactly where the enemy fire was coming from within seconds. Artillery was already plotting fire missions before our lead tank stopped burning, and the P-47s were inbound before the German commanders finished congratulating themselves on their tactical brilliance." German tank crews, by contrast, relied on visual signals, flag communications, and primitive radio equipment that functioned effectively only at short range under ideal conditions. leaving individual panzer commanders isolated from adjacent units and unable to coordinate responses to the rapidly evolving tactical situation, as American forces adapted to the ambush through electromagnetic coordination that processed and disseminated battlefield information faster than human commanders could issue traditional orders through conventional military hierarchy. The engagement reached its turning point at 7:47 a.m. when American artillery pole, directed by forward observers equipped with radio systems that could communicate directly with Sherman tank commanders, began delivering precisely targeted fire missions that had been calculated and coordinated through radio networks that connected every American unit on the battlefield into a single information processing system capable of concentrating overwhelming firepower against specific targets within minutes of initial contact. Von Lüttwitz watched through his periscope as American Sherman tanks that had been surprised and outgunned 3 minutes earlier began advancing through his carefully prepared ambush positions with coordinated precision that seemed to violate basic principles of battlefield chaos. Each tank moving to predetermined positions while maintaining constant radio contact with supporting elements that delivered suppressive fire, smoke screens, and tactical coordination that transformed tactical disaster into systematic destruction of German defensive positions. The mathematical impossibility became apparent when German radio operators intercepted American communications, revealing that the 12 Sherman tanks directly engaged in the ambush were simultaneously coordinating with 47 other American armored vehicles operating within a 15-mile radius, along with artillery batteries, air support elements, and mechanized infantry units that could respond to tactical developments through radio networks that treated individual engagements as components of larger operational systems rather than isolated tactical encounters. By 8:15 a.m., von Lüttwitz had lost 17 of his 23 Panzer IVs and 5 of his 8 Tigers to coordinated American attacks that utilized radio-directed artillery, airstrikes called in by tank commanders, and flanking movements coordinated through the communication systems that allowed American forces to maintain tactical awareness across the entire battlefield, while German units fought as isolated elements, unable to coordinate effective mutual support or strategic withdrawal under the electromagnetic bombardment of American radio traffic. The iconic image that would haunt German survivors emerged at 8:23 a.m. when the remaining German tanks attempted to withdraw through secondary forest roads, only to discover that American forces had already positioned blocking elements at every escape route, coordinated through radio communications that had processed German tactical movements, predicted likely withdrawal patterns, and positioned intercepting forces with the mechanical precision of an industrial process designed to convert tactical surprise into systematic destruction of enemy capabilities. The systemic scale of American radio production revealed itself through an avalanche of numbers that overwhelmed German intelligence analysts attempting to calculate the industrial mathematics of electromagnetic warfare. Beginning with the captured American procurement document dated October 30th, 1944, which detailed electronics production that exceeded the theoretical capacity of European industry operating under peacetime conditions with unlimited access to raw materials, skilled workers, and uninterrupted electrical power. The numbers cascaded through German headquarters like artillery shells, targeting the foundations of strategic planning. 127,000 SCR-508 radio systems manufactured during the third quarter of 1944, requiring 29,000 individual vacuum tubes produced in American factories that operated continuously despite consuming electrical power equivalent to entire German cities, while simultaneously producing 2,847,000 capacitors, 900,000 resistors, 445,000 transformer assemblies, and 234,000 crystal oscillators manufactured to precision tolerances that German industry could no longer achieve even for prototype equipment. American vacuum tube production alone exceeded 847,000 units per month by November 1944, manufactured in facilities that consumed 156 million kilowatt-hours of electrical power monthly, equivalent to the total electrical generation capacity of the entire German electronics industry. While American radio assembly plants operated 3 shifts per day, utilizing 3,400 skilled workers trained specifically for electronics production rather than general manufacturing, supported by supply chains that delivered raw materials from copper mines in Montana, silver from Colorado, tungsten from California, and rare earth elements from dozens of specialized facilities across the continental United States. The captured American logistics summary revealed transportation networks that moved electronics components with the systematic efficiency of automobile assembly lines. 1,247 railroad cars loaded with radio equipment departed American factories during the first week of November 1944, carrying 3,500 complete SCR-508 systems, 890,000 replacement components, 234,000 feet of specialized cable, and 67,000 antenna assemblies, all transported across Atlantic shipping lanes protected by naval forces that included more radar-equipped vessels than the German Navy had possessed during its peak strength in 1941. German economists calculated that American radio production required approximately 12,000 tons of copper monthly, 80 tons of silver, 345 tons of tungsten, 156 tons of various rare earth elements, and 89,000 tons of steel for chassis, mounting hardware, and transportation containers. While German electronics manufacturing had been reduced to scavenging copper from telephone lines, melting down silver coins for essential components, and substituting inferior materials that compromise performance specifications in desperate attempts to maintain any level of sophisticated equipment production. The mathematical impossibility of German technological competition became apparent through production statistics that documented American industrial capacity operating at levels that exceeded German theoretical maximums. 2,340,000 vacuum tubes manufactured during October 1944, requiring precision glassworking facilities that operated 24 hours daily, consuming raw materials delivered by transportation networks that included 89,000 railroad cars, 3,400 trucks, and 156 cargo vessels dedicated exclusively to electronics component distribution, while German vacuum tube production had declined to fewer than 45,000 units monthly despite utilizing forced labor, substitute materials, and manufacturing processes that abandoned quality control standards to achieve any measurable output. American electronics factories employed 234,000 workers trained specifically for radio production, supported by technical schools that graduated 3,400 qualified electronics technicians monthly. While German electronics manufacturing relied on increasingly inexperienced workers, foreign laborers with minimal technical training, and aging specialists whose expertise could not be replaced as skilled workers were diverted to military service. Strategic bombing destroyed training facilities, and educational systems collapsed under the pressure of total war mobilization that prioritized immediate military needs over long-term industrial development. The captured American production schedule revealed manufacturing coordination that spanned continental distances with systematic precision. Vacuum tubes manufactured in Pennsylvania, capacitors produced in Ohio, transformers assembled in Michigan, crystals grown in California, chassis fabricated in Illinois, and final assembly completed in New York, all coordinated through communications networks that utilize the same radio technology being installed in Sherman tanks, creating industrial feedback loops that improve production efficiency through electromagnetic coordination of manufacturing processes across thousands of facilities. German intelligence analysts calculated that American radio production consumed electrical power equivalent to 89 German cities, utilized raw materials that exceeded total German strategic reserves, employed more skilled workers than German electronics industry had ever possessed, and operated with quality control standards that German factories could no longer maintain for any category of precision manufacturing, while simultaneously expanding production capacity through facility construction that added manufacturing capability faster than German bombing campaigns could destroy existing American industrial infrastructure. The wireless interception logs documented American communications traffic that operated at volumes exceeding 200,000 to 340,000 individual transmissions daily across all monitored frequencies, processed through monitoring stations that recorded approximately 234,000 messages per day, while missing an estimated 89% of total American radio traffic due to frequency limitations, equipment shortages, and language barriers that prevented German operators from processing information flows that exceeded human analytical capabilities. Transportation statistics revealed American logistics networks that moved electronics equipment with industrial efficiency. 890 cargo vessels delivered radio components to European theaters during October 1944, protected by naval forces that included more sophisticated radar and communications equipment than German surface fleet had possessed during the entire war. While American truck convoys delivered replacement radio systems to frontline units faster than German forces could destroy them through combat operations, sabotage, or strategic bombing campaigns that targeted American supply depots with increasingly limited effectiveness. The mathematical inevitability of electromagnetic dominance emerged through production numbers that documented American industrial capacity operating at scales that transformed advanced technology into mass-produced commodities. 67,000 complete radio systems delivered to European combat zones during the first week of November 1944, along with 1,247,000 replacement components, all manufactured by an industrial system that treated sophisticated electronics as standardized products rather than precious strategic assets requiring individual craftsmanship and specialized materials that no longer existed within the shrinking German economic sphere. The enemy realization moment crystallized on November the 3rd, 1944, when General Major Ernst Hoffmann witnessed an American equipment disposal operation that shattered his fundamental understanding of industrial warfare and forced him to confront the terrifying abundance of an enemy nation that possessed such overwhelming productive capacity that it could afford to discard sophisticated electronics equipment as casually as Wehrmacht units discarded empty ammunition boxes, creating mountains of waste that represented more advanced technology than German forces had deployed during the entire war. Hoffmann observed the scene through his field glasses from a concealed observation post near the Roer River, where American engineers were establishing a forward supply depot that would support armored operations scheduled to resume after the approaching winter weather cleared. But instead of the careful resource management that characterized German logistics operations, he witnessed systematic disposal of equipment that violated every principle of wartime economy that had governed military thinking since the Industrial Revolution, transformed warfare from aristocratic adventure into mathematical competition between national productive capacities. American supply personnel were discarding 17 SCR-508 radio systems that showed minor battle damage, along with 43 antenna assemblies that had suffered cosmetic harm during forest operations. 127 vacuum tubes that had been removed from radios as routine maintenance replacements, and hundreds of feet of coaxial cable that American maintenance crews had cut, rather than carefully coiling for potential reuse, treating irreplaceable electronics components like disposable materials rather than precious strategic assets that required careful preservation and expert repair to maintain operational effectiveness. Mein Gott, Hoffmann whispered to his aide, Hauptmann Werner Schmidt, as they watched American soldiers loading damaged radio equipment onto trucks destined for scrap metal collection rather than repair facilities. They are throwing away more sophisticated electronics in a single afternoon than our entire Army group has received since the Normandy landings. Each of those discarded radios contains more advanced technology than anything we have ever produced in quantity. The psychological impact devastated German officers who had spent careers managing scarce resources with obsessive care, rationing ammunition, fuel, spare parts, and replacement equipment through bureaucratic systems that treated every component as irreplaceable. While American forces demonstrated industrial abundance that rendered conservation meaningless through productive capacity that could manufacture replacement equipment faster than combat operations could consume existing inventory. Schmidt had written in his personal diary that evening, "The Americans do not repair their radio equipment. They replace it. When a vacuum tube fails, they discard the entire radio and install a completely new system. When an antenna shows minor damage, they throw it away and mount a fresh assembly. When coaxial cable develops problems, they cut it off and install new cable rather than attempting repairs. This is not military logistics. This is industrial waste on a scale that makes mockery of our entire economic system." The captured American maintenance manual revealed disposal procedures that treated advanced electronics as expendable commodities rather than precision instruments requiring expert care. Radio systems showing performance degradation on more than 3 channels should be discarded entirely rather than repaired. Antenna assemblies with visible corrosion should be replaced immediately regardless of functional capability. And any electronic component that required more than 30 minutes of maintenance time should be discarded and replaced with new equipment rather than consuming technician labor that could be utilized for routine installation procedures. German maintenance crews, by contrast, spent weeks attempting to repair individual vacuum tubes, resoldering connections with precious materials scavenged from other damaged equipment, while American radio technicians simply requisitioned replacement components from supply systems that maintained inventory levels sufficient to equip entire armies with backup equipment, creating redundancy that eliminated maintenance bottlenecks through industrial abundance rather than technical expertise. The mathematical reality of American waste exceeded German production by margins that defied comprehension. Discarded American radio equipment observed during a single week in November 1944 contained more sophisticated electronics than German factories had manufactured during the previous 6 months. While American supply depots maintained reserve inventory that exceeded total German electronics production for the entire war, creating strategic disparities that rendered traditional military calculations meaningless in the face of industrial capacity that treated advanced technology as mass-produced consumer goods. Hoffman's final report to Army Group B headquarters, submitted on November 8, 1944, concluded with mathematical precision that German forces could not achieve tactical victory against an enemy whose productive abundance enabled them to waste equipment faster than German industry could manufacture equivalent items. American radio superiority represents not technical advancement, but industrial inevitability. They possess superior communications not because their engineers design better equipment, but because their factories produce sufficient quantities to equip every tank crew with electronics that exceed our most advanced systems, while maintaining supply lines that treat replacement equipment as routine logistics rather than strategic priorities. Yet, the closing thesis emerged from months of accumulated evidence that documented the systematic collapse of German technological advantage through American industrial mathematics rather than battlefield tactics. American victory was not achieved through superior strategy, better training, or tactical innovation, but through the industrial inevitability of electromagnetic dominance, measured in frequencies controlled, channels coordinated, and communications networks that connected thousands of individual weapon systems into a single, information processing organism that could coordinate destruction with mechanical precision across continental battlefields. The loop returned to that metallic click of the radio dial in Oberleutnant Weber's Panzer IV on October 12th, now silent forever in the forest near Aachen, where the frequency spectrum continued broadcasting American voices coordinating movements, reporting positions, requesting supplies, and maintaining the electromagnetic nervous system that had transformed individual Sherman tanks into nodes in a vast network of coordinated destruction. The mathematics had spoken, calculated in vacuum tubes and transmitted through the industrial abundance of a nation that could afford to waste advanced technology while winning the war through sheer productive inevitability, not tactics, but the industrial mathematics of electromagnetic warfare that had determined the outcome before the first shot was fired.